All right, today we're going to pull back the curtain on something we all use every single day, but let's be honest, rarely think about: water management. This is the hidden blueprint, the complex plan that keeps our world running. So let's get into it.
I mean, it seems simple enough, right? You just turn on the faucet and poof, there it is. But have you ever really stopped to wonder about that journey? How does that water travel from a huge flowing river through all that land, all those cities, and end up right there in your glass?
Well, the answer, as you probably figured, is definitely not magic. It's actually the result of some incredibly detailed planning. At its very core, any water management system is this delicate dance between three completely interconnected systems that have to work in perfect harmony.
So let's start by breaking down these three essential dimensions. I want you to think of them as like the foundational layers of the entire blueprint. If you get these, you get the whole picture.
Okay, so here they are. First, you've got the natural system. That's the water itself, right? Its physical, chemical, and biological makeup. Second, there's the socio-economic system, which is all about us, human activities, and how we use that water. And third, you have the institutional system. That's the governance, the rules, the organizations that control it all. And the key word here is interdependent. You can't change one without affecting the others.
Now, let's do a little thought experiment. Imagine you're a planner, and you've been tasked with designing one of these massive systems. Before you can even think about pipes or dams, you have to make two huge, fundamental choices that will shape the entire project from the get-go. The very first question you have to ask is, what's our scope? Before you do anything else, you have to define the boundaries of the problem you're trying to solve. Are we thinking about a huge region or just one town? Are we planning for next year or for the next 50 years? This one decision basically splits your whole approach in two. And this lays it out perfectly. On one side, you've got the spatial scale. That's area-based planning for a physical place like an entire river basin. And the golden rule here is simple. Whatever happens upstream always affects everyone downstream. Then, on the other side, you have the temporal scale, planning for time. This means thinking about seasonal changes, like way more water needed in the summer, but also making sure that the quick fixes we make today don't cause a disaster 50 years from now. The best plans, of course, have to nail both.
So once you've defined your scope, your time, and your place, the next giant question is all about power. Who's in charge here? Who gets to make the decisions? And just as important, how are those decisions going to be made?
And this shows the two main schools of thought. For a long time, the go-to was the top-down approach, command and control. That's where a central group of experts makes all the calls, with very little input from the people who actually use the water. But now, the more modern and frankly more effective method is the bottom-up approach. This is all about the stakeholders, the public, the people on the ground, actively participating in setting the goals. It just makes sense because you're actually addressing the real-world needs of the community.
Okay, so you've set your scope, you've picked your governance style, now it's time to actually build the plan. And it turns out every single water management plan, I don't care how big or small, is built on the very same three pillars.
3. That is the magic number. You got to remember it, because if you get one of these pillars wrong, believe me, the whole thing can come crashing down. So, let's dig into what they are. Pillar number 1, the technical pillar. This is the how. It's all the physical stuff. The concrete and steel, the dams, the pipes, the treatment plants. This is all about the pure engineering challenge of getting water from point A to point B and making sure it's clean and safe. Pillar number 2 is the economic and financial pillar. Yep, the money. Because you can have the most brilliant engineering plan in the world, but it's totally useless if you can't pay for it. This pillar forces planners to think about funding the project, how to cover maintenance costs down the road, and how to manage a budget to make sure the system can actually last. And finally, pillar number 3 is institutional. Think of these as the rules of the game. This covers all the laws, all the policies, and the government agencies that regulate how water is used. And here's a really crucial point. You can get rights to use water, but you can never privately own it. This pillar is what makes sure this shared, essential resource is managed for everybody's benefit.
So you've got a plan, it's built on these 3 solid pillars. Now what? How does this thing actually get built? Let's take a quick look at the process that turns that blueprint into a real-world, functioning project. So get this, before a single shovel ever hits the dirt, planners use these incredibly sophisticated computer models. You can think of them as like virtual sandboxes. They can simulate a 100-year flood, or a sudden population boom, or a severe drought.
This lets them test drive their plans, predict what's going to happen, and find the absolute best solution before spending a dime on actual construction. It's a total game changer.
Once that plan is locked in, the project lifecycle basically follows 4 clear steps. It all kicks off with planning, where you define the problem and what you're trying to achieve. Then you move to build-up. That's getting your team, your money, and your timeline all lined up. After that, it's go time, implementation, where the work actually happens. And finally, you have the closeout, where you look back and evaluate how everything went, what worked and what didn't.
So, yeah, getting water to your tap is, well, it's a lot more complicated than it looks. It's this complex, multi-layered process. And really, at the heart of it all is just this massive balancing act. And here's the big takeaway. This is what it all boils down to. Effective water management is an incredibly delicate balance. You can't just have amazing engineering. That engineering has to be paid for, and it has to operate within a clear set of rules. Real success only happens when those 3 pillars, the technical, the economic, and the institutional, are all perfectly integrated and working together. And that, of course, brings us to the big question for our future. As our world faces these massive new challenges, climate change, growing populations, the systems we rely on are going to be tested like never before, which really forces us to ask, how do the blueprints we use to manage our single most essential resource need to change, to evolve to meet the demands of tomorrow?